Now, potential due to an electric dipole. Okay. Say, suppose as shown in the figure, the dipole that is on the y-axis plus q minus q, separation between these two charges plus q and minus q, that is 2a, and the dipole moment that is from minus q to plus q as shown in the figure. Now we want to find the potential of this dipole at point P, which one is at distance r from the center of the dipole, and the angle between the dipole moment and the position of the point, that is theta. Now at this point P, we want to calculate the potential. Clear? Now see, in previous theory we discussed the electric potential due to a point charge, and we derived the equation of it, that is V equal to kq upon r. Now suppose our charge q, that is negative charge, then simply we have to write the equation for the potential, that is minus kq upon r. It implies that we can say this thing: the electric potential of positive charge at any point, that will be the positive potential, and due to a negative charge it will be negative potential. Here we have a dipole. Dipole have 2-point charges. So simple concept here. First we have to calculate the potential at point P due to positive charge, and then we have to calculate the potential at point P due to this negative charge, and then after we have to take the algebraic summation, because potential is a scalar quantity. Now say, suppose from charge plus q, point P that is at a distance r1, so we can write the potential of charge plus q, that is V plus, equal to kq upon r1. And if point P that is at a distance r2 from minus q charge, then its potential at P, that is V minus, equal to minus kq upon r2. So resultant potential at point P, that is V plus plus V minus. So we can write that is kq upon r1 minus kq upon r2. So we can write therefore V at P, that is equal to kq into 1 upon r1 minus 1 upon r2. But always we take the position of the point from the dipole, that is with respect to the center of the dipole. It implies that we have to represent the equation of the potential at point P in terms of R, not in terms of R1 and R2. Clear up to this one? Now see, suppose here we take the position plus q to center A, that is vector A, and from center to point P as position vector R, then R1, that is the vector joining to the tail of first one to the head of second one. So we can say vector R1, that is equal to vector R plus vector A. Now what is the angle between R and A? So angle between R and A, that is pi minus theta. કારણ કે આપણે કોઈ પણ બે વેક્ટર વચ્ચેનો એંગલ લઈએ ત્યારે બંને વેક્ટરનું ટેલ આપણે સેમ પોઝિશનથી ઇમેજિન કરવું પડે. તો અહીંયા આ એ નું હેડ આવ્યું, તો આપણે એ ને ટેમ્પરરીલી આમ એક્સટેન્ડેડ ઇમેજિન કરીએ તો આર અને એ વચ્ચેનો એંગલ આ આવે. તો ઉપરનો એંગલ થીટા, તો આ નીચેનો એંગલ પાઈ માઇનસ થીટા. તો હવે ડિસ્ટન્સ R1 જો આપણે ફાઇન્ડ આઉટ કરવું હોય તો આપણે આગળ ઉપર 11th માં ડિસ્કસ કરી ગયા કે મેગ્નિટ્યુડ a પ્લસ બી દેટ ઇઝ અંડર રૂટ a સ્ક્વેર પ્લસ બી સ્ક્વેર પ્લસ 2ab cos theta. Exactly like that. R1 that is under root R1 R square plus a square plus 2ar cos angle between a and r that is pi minus theta. બંને સાઈડ સ્ક્વેર લઈ લીધો આપણે, એટલે ડાયરેક્ટ ઇક્વેશન મેં લખ્યું અહીંયા r1 square equal to r square plus a square plus 2ar cos pi minus theta. Up to this one clear? Therefore, we can write r1 square equal to r square plus a square minus 2ar cos theta, because cos pi minus theta that is minus cos theta. Now, on right hand side, if we take r square common, then we can write r1 square equal to r square into 1 plus a square upon r square minus 2a cos theta by r. Now, in the similar way, here we can write r2 square that is equal to r square plus a square plus 2ar cos theta. And now again we take r square common on right hand side, then r2 square equal to r square into 1 plus a square upon r square plus 2a cos theta by r. Clear up to this one? Now here a that is very much less than r, so we can neglect a square upon r square. Now if we neglect a square upon r square, then both these equations we can write like this: r1 square equal to r square into 1 minus 2a cos theta by r, and r2 square equal to r square into 1 plus 2a cos theta by r. Now take square root on both the side. So r1 equal to r into 1 minus 2a cos theta by r raised to 1 by 2, and r2 equal to r into 1 plus 2a cos theta by r raised to 1 by 2. Now take reciprocal on both the sides. So 1 upon r1 that is equal to 1 upon r into bracket 1 minus 2a cos theta by r raised to minus 1 by 2. કારણ કે આપણે નીચે લઈ જઈએ raised to 1 by 2, તો ઉપર ન્યુમેરેટરમાં લખીએ તો minus 1 by 2. Therefore 1 upon r2 equal to 1 upon r into 1 plus 2a cos theta by r raised to minus 1 by 2. Now use binomial theorem. So we can write 1 upon r1 equal to 1 upon r into 1. Now this power will be multiplied with this second term. So minus 1 by 2 into minus 2a cos theta by r. 2 cancelled, minus minus plus. So we can write 1 plus a cos theta by r. Similarly for this one, 1 upon r2 equal to 1 upon r into 1 minus a cos theta by r. Clear up to this one? Now substitute the values of 1 upon r1 and 1 upon r2 in this particular equation. Okay? So potential at P that is equal to KQ into 1 upon R1 is replaced by 1 upon R into 1 plus A cos theta by R minus 1 upon R2 is replaced by 1 upon R into 1 minus A cos theta by R. Take 1 upon R common. So KQ by R into, simplify this bracketed term. So 1 plus A cos theta by R minus 1, and this minus plus A cos theta by R. 1 cancelled. So we can write this is equal to KQ, or we can write K, that is 1 upon 4 pi epsilon 0. So Q upon 4 pi epsilon 0 R into this plus this, that is 2A cos theta by R. Therefore, potential, that is Q into 2A cos theta upon 4 pi epsilon 0 R square. Clear to all of you? Now, Q into 2A, that is the dipole moment P. So we can write V, the potential at point P, that is equal to P cos theta upon 4 pi epsilon 0 R square. Or you can write that is equal to P dot R caret upon 4 pi epsilon 0 R square. Here you can see this thing, the potential of electric dipole that proportional to 1 upon R square. And it depends on theta also. It implies that it depends on the angle between dipole moment and the position of the point. Clear to all of you? Now, the special cases. Electric potential on the axis of the dipole. Suppose we consider the point on the axis towards positive charge, then theta will be equal to 0, because the dipole moment and the position vector both will be in the same direction. So if in equation of potential we take theta equal to 0, then we can write potential, that is P cos 0 upon 4 pi epsilon 0 R square, but cos 0, that is 1. So potential, that is P upon 4 pi epsilon 0 R square. But if we take the point on the axis of the dipole towards negative charge, then the dipole moment, that is from negative to positive, and the position vector that is towards negative, it implies that the angle theta, that is pi. So potential at the point, that is P cos pi upon 4 pi epsilon 0 R square. Cos pi, that is minus 1. So potential at that point, that is minus P upon 4 pi epsilon 0 R square. Clear? Now potential at any point on the equator. So at any point on the equator or equatorial plane, theta, that is 90 degree, angle between the dipole moment and the position vector, that is 90 degree, and cos 90, that is 0. It implies that potential at any point on the equator of the dipole, that is always 0. Clear to all of you?